Hello everyone, welcome back to our channel Data Tech. I'm your host Anand Kumar. In this video, we will be building end-to-end data pipeline within the AWS environment. This video is divided into three sections. Section 1, where we will look into the architecture used in this project, and we will also deploy this architecture using infrastructure as a code. Section 2 we will be focusing on Pyspark, where all the extraction, transformation, and loading will happen. And finally, we'll summarize all these key learnings in the section 3. So let's start. In this section, we will explore the AWS architecture required to establish an end-to-end ETL pipeline. The architecture involves several components, starting with the storage layer, S3, that serve as the source of the data pipeline, and after that we use AWS Glue to catalog this data using the crawler, and subsequently we process the data using the Pyspark within the interactive Jupyter notebooks in Glue. In real world, like whenever we develop something in Jupyter notebook, that is considered, or it serves as pretty much like an interactive or a development environment. Once this data is processed, it is finally loaded into Redshift. To build this architecture, we going to define all the necessary resources and their configurations in a YAML file, which we will use as a template in the CloudFormations. And the template which I'm going to use in this video, you can find that template GitHub link in the description. So now let's jump to the AWS console. So first thing, log it into the AWS console. After logging, search for the CloudFormation. Once you are in the CloudFormation service, click on Create Stack. And here you can see we have three options. Like if we already have a ready template, we can use this. If we want to use some sample templates, we can select the second option, and third is just to create a template using the designer. But as I already mentioned, we have a ready template, we're going to use it. So we will upload the template file from our local drive. Let me click here, then click on choose file. Select this, click on here, and after that click on next. We give it a name, ETL, then click next. Rest of the things we'll keep it to default. Again, click next, and in the end we'll just acknowledge the AWS CloudFormations conditions. Click on submit. This might take few minutes, so I will pause the video and return once it's complete. Now that the stack is successfully created, let's check few things. So we're going to check S3 buckets, Redshift cluster, and Redshift connection in Glue. So first, let's go to S3. Okay. So here we can see both of our buckets, ETL data bucket, ETL source data bucket. Now let's go to the Redshift cluster. We go to Amazon Redshift, and we created the not the serverless but the provision one. So we'll go, yeah, so we landed on provision cluster, and we can see ETL Redshift cluster is also available. And the next thing I want to check is our connection. So we'll go to Glue. We'll click on data catalog, click on connections. And here we have the connection to Redshift demo connection. Now we will move to the next section. In this section, our primary focus will be on Pyspark script, which we develop in Glue Jupyter Notebook. Before we proceed, we need to upload the source file to S3, and then we will catalog the data using crawler. So let's begin by uploading the data into S3. So in AWS Management Console, we go to the S3 service. And for our ETL, we'll upload the data to source data bucket. Click here, click on upload, click add file. And here we're going to upload a sales data, which is in a CSV format. And you will find the GitHub link for this data in the description. Click on upload. Okay, so once the data is uploaded, now we will create a crawler and a database in AWS Glue. So we'll go to Glue, click on hamburger, expand the data catalog, click on database. So we'll add a database. The name will be sales DB. Click on create database. And for the tables, we will create a crawler. We click on crawlers. So we already have there is an existing crawler with the names of sales crawler, but I'm going to create a new one. Click on create crawler. I'll name it just sales. Click on next. I'll add a data source here. So that will be our source file, which we have in our S3. So I'll browse to that. Click on this. We go here, select this. And we click here. We'll add that as a source. Click next. We select a role. So ETL, if you remember, like our stack name was ETL, and from there we can identify this is the role which is created by our stack. So I'll select this. Click next. Choose the database. So we have sales database. Then next, and we keeping the frequency on demand. You're not scheduling it, so we click next and create the crawler. And now the crawler is created. The next thing we need to do, we just need to run the crawler. So before that, I just want to make sure we don't have any tables. Yes, we don't. So I'll run the crawler. So we created this crawler named sales. So I'll run it. I'll select this and click on run crawler. Okay, it will take like a few minutes to complete. In the meantime, we will start looking into the ETL jobs which we have to create using the Jupyter Notebook, and it's going to be an interactive notebook. And the reason, because when we develop something in an interactive mode, it gives us the opportunity, or it gives us the chance to look out our output. So we make sure that we are headed in the right direction. So whenever we developing something, we want to make sure like we don't make mistakes. So that's where like developing things in notebook can be helpful. So we'll click on, we expand this data integration and ETL. In ETL jobs, we have two options. We can click right directly on ETL jobs. From here also we can create a notebook, and we can create a notebook from notebooks too. So here, if you see, once we click here, like we get 6 options, and here the Jupyter Notebook option is there. So we click on this, and it asks us whether we want to create a new notebook from scratch, or we want to upload and edit an existing notebook. So I already built this note, like I already have a notebook which I created, but don't worry, I'm going to explain that notebook step by step, and the link for that notebook also you will find in the description. But let me upload that notebook. So I'll click this, choose the file, and this is the file name, and click on create. The job name, I'll give it sales aggregation, and the role, we'll pick again the ETL roles one. So this is the role which our stack created when we use the cloud formation to build the whole infrastructure. So select that, click on Start Notebook. It will take some time. In the meantime, we'll go back and see if our crawler have created or our crawler is completed. Oh, I haven't saved the changes. Let me wait here. I'll open another tab just to check. I'll go on crawler. Yeah, I can leave this. And it says the last run has succeeded. So we'll go and click on tables. Yeah, so now you can see we have a table name sales records underscore CSV database sales database. So as I mentioned in the beginning, we need to catalog the data using crawler. So that activity is done. And now let's go to the notebook. Okay, awesome. Now this is the notebook which will perform all our extract, transform, and load in Glue. And as I mentioned, it's an interactive one. So I'll explain the code step by step. The first cell which you're seeing here is the help, and this is an optional cell which basically give us the detail of all available notebook commands. So it's pretty much like a help option which we see in most of the programming languages or Linux systems and all those kind of things. If you want to run, you can run it. If you don't want to, like as I say, it's optional, so you can skip it too, but we're going to run it. And after that, the output will be something like this, like it's welcoming and giving you the list of magic commands which we can run. Okay, now if we go to the next cell, so this next cell is basically here we are importing the required libraries and setting up the Glue configurations. So if you see at the top, anything which is started with percentage is the Glue configuration. So if we look at the first one, this is basically specify the idle times in minute. The second percentage Glue version specify the version of the Glue. Then third is like number of worker nodes for the Glue, worker type, and the fourth one is the worker number of workers, and the last one is like specify the connection for Redshift. And after that, we are importing the required libraries, and then we are initializing the Spark and the Glue context in these lines. And Glue context is the main entry point for AWS Glue ETL. So let me run this to initializing Spark and Glue context. Now we will start working with the data. So the first thing, we will create a dynamic frame from the table in the AWS data catalog. So as you can see here in this line, we are using the database and the table name from the AWS data catalog, which our crawler created by running on the S3 CSV file. So if you guys are not familiar with dynamic framework, or you might be confusing what is this dynamic frame. So dynamic frame is nothing, it is something similar to the Spark data frame, but it have like different syntax to perform actions. So for example, if we look at the line number second where we are dropping the null fields, so here the syntax is quite different than how we do it in Spark data frame. So in Spark, basically, if we have a data frame, we do just drop NA and it will drop all null records. But here the syntax is different. So the only difference between a dynamic frame and a Spark data frame is basically how the syntax is defined and how the syntax is used to perform actions. Since I'm very comfortable with Spark, I'm going to convert this dynamic frame to a Spark data frame, and after that I'll use all like Spark functions and all actions which I'm very familiar with. But till here what we are doing here, we just reading the we are creating the dynamic frame using the data from AWS catalog table, and after that we are dropping any null records and printing the schema. And this is what I was talking about. Like in these two, like here we are converting the dynamic framework to the Spark data frame and then displaying a sample of the data. Okay, so before that, let me run this. I forgot to run this. Let me run this, and let's wait for its output. Now, next, in this one, we basically just converting dynamic frame to a Spark data frame, and then we'll display the sample of the data. Let it run. In the meantime, I'll explain what we're doing in the next cell. So in the next cell, we basically, okay, that is done. In the next cell, if you look here, we are basically doing the date transformation. So if we look up above, ship date and order date, they both are string, but in this section, we are performing a data type conversion. We are converting them into the timestamps, or I'll say we are converting them into dates. So that is what we are doing here, and after that we are showing it. And here we have to use like a legacy, like we need to set Spark SQL time parcel to legacy. The reason being is like the Spark used in this Glue is Spark 3.0, which does not support this syntax but for that we can set this property as legacy and it will work smoothly. And after that we just show, like we are converting them into dates and showing them as an output. Okay, so you can see the order date change here. Like if we look at the output here, like it is it's different, but if we come here, it is converted to a date. And after that we are performing simple aggregations on reason, country, and order date and the quarter. So if you can look at this here, we are doing a group by reason, country, and from order date we are extracting the year and we giving it as an aliases as a year. Same thing again, like, but this time we are extracting a quarter, aliases as a quarter, and then we are aggregating the like a total revenue, total cost, total profit, and the aliases like this. And let me run this. And this one, okay, once the aggregation is done, in the next cell we are just like order them by year and quarter, printing it and checking at the count. Let's run this again, and it will take a couple of seconds. And if you feel like your notebook is slow, you can you can increase your worker nodes and all from here, like at the top, which I mentioned. If you scroll at the top, we can increase, but it will come with a cost. So just be cautious when you're doing this. Okay, so we're done here too. We just sorted by year and quarter, print the number of count. This is 3,317 records. After that, we just again renaming these fields because the name, the field names were pretty like big, total revenue by reason and country and all. We just renaming them again to that, and after that we are printing them again using year and count quarter in the order by. So if we click this, you will see this, we'll get the output. And now, like so far, so what we have done, we have sourced the data from data catalog, which is built on top of S3, and after that we have done some transformation, like we converted the strings to the date and performed an aggregation, and now we are going to load this data into Redshift. But before loading data like this data set into Redshift, we need I'm going to do one more thing. I'm going to convert our Spark data frame to a dynamic frame so we can load it easily into the Redshift cluster. Let me click on this. So in this shell, we are converting the Spark data frame to dynamic data frame, and after that we are just printing the output of it, and it will look like a JSON file. As you can see, this is in a JSON format, And after that, here, this is the code. This in this cell, we are basically writing that dynamic frame to a Redshift. Okay, now so our Redshift upload is finished. We will go into a Redshift cluster and check if data is loaded there or not. So one thing, like if we look at like in our database, we are using the like this is the database table name. So public relation sales, regional sales is the table name, and database is dev. Okay, so we'll go to our Redshift cluster, click on query editor version 2, and okay, awesome. So now we will expand our ETL Redshift cluster. So if you remember, our database is dev, so we'll expand this. Public is our schema. Okay, we have one table. Let me explain this too. So table is regional sales. Okay, let's do one thing. Let me delete this. This is something from my old runs, but let me run a count on this. So 3,317 is the count. That is what we had in our aggregated. If there was a place yeah, here. So here, this is the like number of rows in our aggregated data sets, and same is here. So now the data is loaded into Redshift. So overall, if we summarize this code, so overall this code fetches sales data from S3 in a CSV format, catalog it, clean, transform, and perform some aggregations, and finally write that data to the Redshift. One final point to be considered, that once everything is finalized and validated in our Jupyter notebook, we have the option to save the notebook as a job, and after that we can schedule based on our requirement. And once we save it, like all this notebook code is converted into a Pyspark script, which is used in the job. So basically here we developed our code in the interactive environment. Once everything looks good, we can productionize it, just save it and schedule as per our need. Lesson learned from this video. Lesson 1. How to construct the data engineering architecture using infrastructure as a code. Lesson 2. The process of writing Pyspark ETL jobs in AWS Glue, more specifically in the Jupyter notebooks. Lesson 3. We also covered like working with dynamic frames and the Spark data frames for more flexibility in data processing in Pyspark. And finally, once everything is validated in the interactive mode, we can convert our jobs into a production ready state by simply saving them and scheduling as per our requirement. Please remember to clean up your stack to avoid any unnecessary changes. That concludes this video. Thank you. Happy learning.